Okay, so in this presentation, it's about the product portal. As Rui said, I'm a Machiel, and this product portal has been made a bit by me and more recently by José Manteigueiro, who has been working recently very hard on it. But it has a long history, and in the past we had lots of contributions by Rui, Paul Crocker, Rui Cardoso, Rafael Couto, and André Rodrigues, University of Beira Interior. So I also show here the figure, which you should now know very well by now. It's been shown in many presentations. So in the previous one by Anne, it was about the analyze centers, but now I will be talking about the product gateway. So all the data comes here, enters the ecosystem to the data gateway, is being analyzed by the analyze center, and then the positions and velocities, they're sent to the product gateway where they can be downloaded by the users. And then also these velocities are used to compute strains, which can also be downloaded by the user. So this is just to position the product gateway in the rest of the TCS GNSS data and products. So now I'll talk about the product portal. So here is the URL. So gnssproducts.epos.up.pt. If you go there in a browser, you will see this. And the first thing it will ask is to accept cookies. So let's accept cookies. And then you have this welcome pop-up. So it shows the list of analyzers and combination centers discussed in detail by Anne in the previous one, INGV from Italy, Manteigueiro from Sweden, LTK Euref, Hungary, ROB, Royal Observatory of Belgium, from UGA from France, and Warsaw University of Technology of Poland. We provide daily and weekly time series, and they're given in various reference frames. Then you can download the velocities, and we also have a strain map which you can download. In the bottom, you have the links from the GNS Data Gateway, which was discussed by Mathilde and Jean-Luc yesterday, and the M3G Gateway, where you can enter new stations or can enter their site log or change and update them. So let's go. So the first thing the user will see is this map with all the stations. So, and then these are the stations that are providing products. And then you can have time series, velocities, and strain rates, and also power spectrum I will talk later about. And then here you have filters, so you can already select some of them to limit the number of stations that you're seeing and want to download. So you can use the sliders to minimize it, and the networks, and you see that is update. I already want to say the network here, EPOS, we are in the pre-operational phase. So the stations, some of them are not yet EPOS station, but they're providing data, but that can be analyzed by the analyze centers, but they're not providing yet the RINEX. So this EPOS network is actually kind of just a name to capture all the stations which are not in a network or which we don't know the network name. And then here you can filter the analyze centers. So you can also filter them, and you see that data. Okay, before I show any time series, I want to go about the information. We have here a button, information. So analyze center, documentation, and frequently asked questions. So analyze center, that's the first thing I will show. So we have here the list of analyze centers, combination centers, INGV from Italy, LM, Manteigueiro, LTK Euref, ROB, UGA from France, and with Euref. So You can click on them and then you can already see some description about what they are. So with the URL and then the time series. So which software they were computed and in which reference frame. So the velocities that was already discussed also before. That was in the meter software in the case of INGV. We will also use that. So you can here find some quick information. So INGV and UGA were the EPOS group. And then you have the ROB and the Wood of the EUREF group. Wood is a combination center. So Anne already listed all of them. Here you can see they're also listed here. And here in LTK Europe, it's the densified solution. You also have all those analyze centers that contribute to the densified. So they provide solutions, velocities, or time series, which then by Ambrus has been used to compute the densified solutions. In Landmeteriat, they are computing the strain rate, and they have been collaborating with NOAA from Greece. So ROB gets them also from UTRF. So here it's just a list and you can view it. Then if we go back and go to the documentation page, here, here you have very detailed information. The first is just for the analyze centers themselves, how to upload it. That's not very useful maybe for the user, but for the people who have to upload the products, it is. And then here you have PDFs files which show all the information what's unsaid in the previous documentation presentation about outliers, how they were detected and removed, discontinuities, offsets, how they were detected using metadata or other methods, and how they were treated. So here, for each analyze center, you can read about that. And here, the processing procedures. These are reports and documents that have been collected over the years and written. So this one especially, it's more than 100 pages, and you can find lots of information. So if anyone wants to read more about the background information about how the things were processed, analyzed, this is a good document to find it. It's very detailed. So, yeah. Then the final one is about the frequently asked questions page. So here we state some general questions with answers. What's EPOS? I here only want to point out that we have a landing page. So we have also a nice landing page where you can find all this information. So if there, it's also good start where you want to find more information. And for here the list. And then for now, maybe it's what I want to emphasize more is that there is here an example about the RESTful API. So it shows how you can automate this downloading. So I will go into detail, but here if people want to come back, they can find here an example. Okay, so let's try to look at some time series. You can click on here, and then you see it. You can see the time series. But now let's do it here. Also in the search box, search for it, and it comes here. So it gets updated, and then here you have a button to see the data availability or the product, so the time series. So they're in green, it's available. So we have data from 2008 to 2020, and then in the end, because the year we have not received it. So this is that. And then, so let's click on it. So here appear the time series. You can see that here. So you have the various steps, the various analysis center that provide time series, INGV, UGA and ROB with the Europe group. The densified solutions of Ambrus will be added next week or in the coming days. So they are ready, but they need to be put on the product portal. Then if you go down, these are the east, north, and up component for the years. So you can use the browser. Then we download them. You can download them as a PNG file, as an XML, so a markup language, the format, so all the data of the time series comes in text, with text, it's good for computers. And the PBO format, the plate boundary, it's a text file, I'll come back to that. Then the meters, so meters also has its own time series format, so if you download it in this format, you can directly put it into meters to estimate your velocity. And also you can use the Hector. Since I'm involved, of course, Hector should be there too. That's also a simple text format and you can download it. And then all these data products are provided using the CC BY license. So if you go down, for each analyze center, you can see the 4-character name, the analyze center, which we're seeing, sampling pyramid, it's daily, the reference frame, the version, and then the DOI. So the DOI, if products come with a DOI, you can see it here, and then the start and the end epoch. Okay, so let's try to get to download it. You cannot do that because the philosophy of the product portal is that you can browse and see what's available, but to download it, you have to give your email address. This is done for 2 reasons. The first one is we would like to know who is using the product portal. And secondly, some of the requests you are making to download are sent back by email. So we need the email to send the results. So, but if you don't have an account, you can sign up. You give your first name, last name, email, and select a password. And then you can log in with your email and name, or you can use other login options. So one of them is the EPOS site. EPOS, it's EPOS, as we explained yesterday, our TCS, GNSS data and products is only one of the various TCS that exist. There is seismology, geology, near fault observatory, and they all should be working together. So all the data available at the various portals at the other TCSs, you should be able in the future to all access them with a single login and password. So that's for the future. Let's go back. The other one is the Google. It's more common. It's log in with your Google account, or you can log in with ORCID for researchers who have an ORCID account. Type in and you can log in. Let's go back. So let's log in. I'm now logged in as Machiel. Let's go to floors. There, and download the PBO. So it's downloading. It doesn't know the application.tos, but okay. So I have done that. Here's floors. It's the 4th time I downloaded it just to make sure for this presentation. So I open it in a simple text editor. So you can see on the first line, it gives the reference frame. And then also the 4-character ID, floors, long name, first epoch, last epoch, release date, reference position. So here, the first lines, they explain the columns of the data. And the real data, they start here. So here, in this case, the data starts at 2008. And then you can see here the reference position in Cartesian here. And then the uncertainties. So This is the format people then can use in their software to get the time series. Another format is then the hecto format. Which is, it's similar, but it has less information. Modified Julian date, east, north, up in millimeters. So that can also be used. Let's go back to the presentation, to the time series. So I've shown you, you can download it and then show you the various formats that exist. So now let's go to velocities. So velocity is already showing here. Let's go in. Velocities are shown by this line, with the line gives its orientation, so where the velocity is pointing to, and then the length of the line is the magnitude of the velocity. These are velocities with respect to stable Europe. So most stations in Europe are not moving. It's only in Italy when there's tectonic activity, where you can see some motion. And of course, in Greece and Turkey, there's a lot of deformation, which is clearly visible. And of course, you can again use the sliders to select, where EPOS is this general collective term to denote stations which have not, for which we don't know the network, or we did not have the information. And then you can also use the analyze centers. You can correct for that. So select station. In a single view, you can see here the velocity with respect to stable Europe for the northeast and up component. This is then the EPOS EUREF solution, the version number with the reference frame IGS 14. The same for IGNV, UGA, where you also have, if it's known, we can also are giving here the DOI number. And then these are velocities with respect to stable Europe, but you can also check, you can play around and you can see no net rotation. So Terceira, if it's absolute velocities, then they are moving northeast. Europe is moving a bit to the northeast. You can also check the velocity with respect to North America. So it's still not around zero. So Terceira, although it's close to the mid-Atlantic ridge, it's more Europe than North America plate. So you can play around with that. Again, these data are provided with the CC BY, and but you can, so let's download it. So let's do a download for let's say ROB. So it's downloading them. Okay. And then I already did that before. It's there. So when you open that on the first line, you see where the data is coming from. So all the data is put on an FCFTP site. It's by ROB Europe, the reference frame, release date. So again, the first lines in this PBO plate boundary format, they're explained. And then here are the data. So this is how that works. So, okay. So far I've been talking about a single station. So let's go back to the time series, zoom out a bit. But suppose you want to select a region. So then you can, instead of the sliders, you can also use here a rectangle. So you can draw a rectangle. I will remove this here. It gets updated here. And then, so if you make a mistake, you can click on this bin symbol. If you see your mouse symbol changes when you go to the border, and you save it. So this is how you can work with it. Let's draw it again. And since I'm logged in as Machiel, you can download it. Then the selection, you give your email address, and then you can choose the format. So these are the formats I already talked about. So JSON, Hector, or PBO, submit, and then you get a download request. And within a few minutes, you should get in your email box the notification that you have received the product as a zip file. So that's that. And the same for the velocities. You can select it. Let's do another region. And then download selection. Then the email again. And then you can choose here the various analysis center, combination center that you want. You can do multiple, so you can add those. And then you can choose which format you want, JSON. Then you have the east, north, up. You check this slider, or the geocentric Cartesian ones, slider. And then, or you choose the PBO format, and then you submit the request. Again, it's the same, the download, and then after a while in your inbox, you get the file. So these are sent to you by email. So before talking about the strain rates, I would like to talk about the power spectral density. So if you go again to a station, let's see. So all the time series have been estimated with Hector, and then from the observations, the secular trend has been subtracted, and the residuals have been used to estimate the noise. It's well known that GPS time series have temporal correlated noise that follow quite closely a power law model. So in blue, you will have here the power spectral density observed from the residuals, and then in red, you have the fitted noise model, power law plus white. It's almost pure power law. And this here, the thin red lines give you the 95 confidence interval. So why do we do this? This is a bit to give you an indication about the noise levels. If there's a lot of noise at the low frequencies, your trend estimation will be bad. So this is an quality indication for your time series. You can use that to see if a station is good or bad. And we have done that for the various analysis centers for all the time series. Okay. Then finally, there is strain. The final product is strain rate. So these are the last in line. We have now Manteigueiro is working hard to provide more strain maps, but for the moment we have this one, which shows the central part of Europe. So it shows the dilatation, and then you can also here visualize the maximum strain or the minimum strain or the shear stress. And then you can find here the documentation. So the explanation how the strain was computed, and you can download it so you get the file which was used to plot this these data. Okay. So far I've been talking about the products using this browser, but if you have some automatic way of doing it, so it's very good to browser to explore what's available, with products they are, how long the data is. But if you have some repetitive or you want to automate it, then it's not so convenient, and then it's better to use the API. Paul yesterday already talked about Glass, and the browser is just on top of the Glass framework. So we have a Glass node, and then you can browse the API. So here, if you want to automate your queries of the products, this is the best way to get to know this. So the first, I just want to give some examples. So let's suppose you want to know which stations have products. So you go to this, get products. It's a nice swagger. And then you can, here are some examples. And so let's find all the stations with products within a region. Here, a rectangle. Try out. Here. Copy in. So let's see if it works. So this is live querying the database, and yes, it's working. So here you can see in a JSON object all the stations, X, Y, and Z coordinates with products. So this is, you can play around with that, and then you have here your curl command, which you have to automate. But so this just gives you an idea how to work with that. Another one, which is very nice, is the velocities. So here, the velocities. So here it's the products, velocities, marker, analyze center, coordinates, and format. So let's try it out. So analyze center, let's say you're a BRF. Coordinate system, east, north, up. Format, JSON. And let's do the floors one again, execute. So it's directly here. So you get this JSON object back where you can see your reference frame. You can see the east, north, and up velocity in meter per year and the DOI. So here again, you have then here the curl command, how to get it. So this is a very nice way to query also the product portal or to get the products from our TCS. So then finally, I want to say a bit more about how to get these RESTful APIs in a Python example. Okay, where is my key? So here I have a simple Python script. It's in Python 3. It makes use of the request module. So when you write your Python script, you have to import that. And then here I define just a helper function to get the basic URL. So this is you put that in front. And then here is the Swagger function. So I showed you two before about products, velocities, marker. And this one here, it's about stations to get within a box. So all the products here, you can put here the limits, geographical limits. And so it's calling the RESTful API using the request module, get command, and it puts the result in this variable, resp. And then if something goes wrong, an error is raised, it's shown. If it goes well, then this is converted into a JSON object, and then for each object in here you can analyze it. So it's like a dictionary, so you can select the block you want, and then you can select from that. So this is with a subblock. So here I select the 4 character ID, the first 4. Then the properties. So this is subblock, you select it, and then you can get the city, the dummy. So this is the way you do it. You get your URL, you get here the Swagger, the API command, you get it, and then you convert it into a Python and then treat it as a dictionary in the rest of your Python script. So it's pretty easy. So this is also the way you have to do it. This is the principle to get for velocities. You change it here into products velocities marker, and then you can, in an automatic way, get your velocities. So this is a bit what I wanted to tell you. So I would like to thank you for your attention. And if there's any question, I will try to answer them.
Hey, thank you. We have already one question. Please, if you have any also more questions specific about the products portal, please also let us know. But there is one question already from Farah Mars. Sorry if I don't pronounce very well the name. So I think it's also quite a comment, but please, can you make your question?
Hello, everybody. This is Farmars Del Forushan from Manteigueiro, Sweden. Thank you for the presentation. Actually, yeah, as you said, this is not a question. This is kind of comment. And I noticed, I think, when changing the reference plate for the velocities, the velocity vectors on the map was not changing. I think for the visualization will be interesting to change it as well.
Yeah, no, that's was also, I have got this comment also already from my members of the EPO within the group. Why it's not been done yet is also it's for the moment it was pretty optimized for speed. We have to work on getting it better. So for the moment it's like this, but of course we will improve it, and then because then if you do absolute velocity plate, no red rotation, it should be the long factors, and so it should adapt. Yes, but it's we're in the pre-operational phase, so these are the kind of features we have to add to make it more attractive, of course.
Sure, thank you.
No, and we really appreciate, this kind of feedback from all of you. This is also one of the additional reasons to have it to do this webinar is hoping to have feedback from you. I'm not sure if there is any other question from Machiel. I'm not seeing here in my chat, but okay. If not, I would suggest that we break for 10 minutes for the people that really need to have a coffee. But as I was proposing in the beginning of of today, maybe will be nice to anticipate the session of question and answers in order that we can have a longer session, and to ensure that everyone will be have his questions answered. So we can start now with this 10 minutes break, and in 10 minutes we will reconvene for the last session. So don't go away, just stay around, and we will be back in 10 minutes. Thanks.